Okay, this problem that we're going to do here, it's probably one of the most difficult problems I've had to do so far in my physics class. It'll probably be the most difficult for you to follow so far. The scenario we have here is all you're given is the question is, Jimmy is sliding down a hill that is 50 meters long, and it takes him 32 seconds to get to the bottom. He measured the angle of the hill with his phone app to be 10 degrees. What you need to do from those three variables, what you need to get from all that, is what is the friction coefficient. And again, the friction coefficient is the amount of energy or the amount of force resisting him. Okay, so where do we even begin on here? Well, let's think about this. We're going to find acceleration first. And acceleration equals F net divided by mass normally. But in this case, we're not going to be able to find that. So what we need to do is, if you remember this equation, VO squared equals V squared equals VO squared plus 2 times acceleration times change in x. Okay, well, do we know our initial velocity? Yes, it's 0. Okay. Do we know our final velocity? No. How do we figure that out? Well, to know that, you need to find your, you need to know this equation. Your average velocity equals distance divided by time. And that would be 50 divided by 32, which equals, give me one moment, divided by 32, which equals 1.56 meters per second squared. Okay, you got that, but that's not your final velocity, that's your average velocity. Well, final velocity equals 2 times the average velocity, and that's important that you know that, because you're not going to figure out this problem. There's another way, there's another equation you could do, but for this one you're going to need to know that. Okay, so we just multiply 1.56 times 2. And we get 3.12. So our final velocity equals 3.12. Okay, we're on our way to finding acceleration. So 3.12 squared equals 0 plus 2 times acceleration, which we're trying to find, times our change in distance, which is 50. So we're going to get 3.12 squared equals 9.7. And we're going to divide that by 2 to get rid of that. 9.7 divided by 2, 4.85. Equals acceleration times 50. We'll divide by 50, divide by 50, and we get our acceleration to be extremely small. We get our acceleration to be 0.097 meters per second, which is ridiculously slow. But I didn't anticipate that, so the friction coefficient is going to be even weirder, but we'll figure it out anyway. Okay, now we have our acceleration. Now we're going to go back up to this one. First thing we're going to do is solve our components like the other one. So this is 10. And we'll find this one, and the weight equals mass times gravity. Okay, so we've got that. W equals mg. Okay, now we're trying to find our normal force. Well, our normal, actually, let's just look back, so I don't have to waste time on this. Our normal, one moment, please. Okay, let's see. Adjacent over hypotenuse. So cosine equals adjacent over hypotenuse. So let's just do this right here. Can you see that? Okay, cosine equals adjacent over hypotenuse, cosine 10. Undo to find the adjacent, which is n. H hypotenuse, which is mg. You see that? The hypotenuse. See if there's a 90-degree angle here. This is the hypotenuse. It also equals mg. So we're going to say mg cosine 10 equals a. But a is adjacent, which is n, because this is adjacent to it. So n equals mg cosine 10. Okay, we got that. Now we'll find one more. We need to find our wx. Wx is opposite over hypotenuse. So, right? Sine. So sine equals opposite over hypotenuse. Sine 10 equals opposite over hypotenuse. And we know hypotenuse is mg again. So sine, actually mg sine 10 equals opposite. And our opposite we know is our wx. So mg sine 10. Okay, now we know our components. Well, let's go up to our acceleration. We know our acceleration. Acceleration equals F net divided by mass. F net is Wx minus F. F, our little f, is friction. Friction equals mu, which we're trying to find. This is our friction coefficient, times normal force, all over m. So at this point, since we have our acceleration, we have Wx, we have F, we need to just plug it in. So we're just gonna, it's gonna get a little messy, like it's gonna expand quite a bit, but you just gotta keep track of it and you'll be fine. So let's plug these things in here. Acceleration equals Wx. What's Wx? Right here. Equals mg sine 10 minus F. What's F? Well, F is mu times n, and n is actually mg cosine 10. So minus mu mg cosine 10 all over mass. Well, at this point, you should hopefully notice something. That there is an m, mass is in each one of these parts, so we can take mass out of the equation. So we're left with gravity sine 10 minus mu gravity cosine 10 equals acceleration. Well, gravity, which we know is 9.8, we can do that multiplied by sine 10. So let's put that here. 9.8 times, what was it? Sine 10. $1.7. Okay, we'll just write that up here. 1.7. And then we can also go over here and do gravity times cosine 10. Cosine 10. That's 9.65. Okay. Next step is to subtract this to get it, so we can get it mu alone. Well, we know acceleration is 0.097. We're going to subtract 1.7. In this case, acceleration is really not going to matter. It's not going to change your correlation coefficient a whole lot, but you still need it. So 0.097 minus 1.7, and get a negative 1.63, 0.6, excuse me. So right now we have negative 1.6 equals negative mu 9 times 9.65. We'll divide by a negative 9.65. And so negative divided by negative 9.65. and we were left with the 1.66 equals mu. So that's our correlation coefficient. Oops, sorry. This right here, 1.66, is our correlation coefficient. So without knowing the mass or the acceleration right away, only knowing really the angle, the distance, and the time, we were able to figure out that 17% of the force of the mass is resisting that block when it is going down that hill. And that's a good, it's a right answer, because most of these correlation coefficients in these problems are going to be around 0.1 to 0.3-ish. Because anything bigger, you're just getting, it's most of your problems are going to be like this. So hopefully that helped. Hopefully it was easy to understand. If you have any questions, go ahead and ask me. Thanks. Bye.